All right, we're back. We're on page 329, and we're going to do this last problem. So let's see if we can do it. A square sheet of cardboard, 18 inches on a side, is made into an open box, meaning there's no top, by cutting squares of equal size out of each corner and folding up the sides along the dotted lines. Find the dimensions, or, nice, typo in the last like six words, of the box with maximum volume. So let's see if we can do this. So this is a super famous problem. You probably did this in Algebra 2 using a calculator, I would guess, when you do those kinds of like application problems, I guess they're usually called. So let's see. So we have, I guess we'll use blue here. So this is supposed to be a square. I struggle. It's all right. And what we're going to do is we're going to cut. So you're going to cut squares out. Cut, 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 cut. I'm just going to keep saying cut, 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 and then blah, blah, blah. So these are all the same. So then also you're going to go like all the way across, all the way across, all the way across, all the way across. Okay, so now what happens to this? So we get rid of, so some of these are gone, right? So what's going to happen is we're going to get rid of this, this. I don't know how we're going to like connect the sides, maybe with tape, I guess, glue, I don't know. Get rid of those. So then the overall base of the box that we're going to make is kind of here. So like the base. And then the other four things are sides. So we're going to end up with something that looks kind of like this, right? We're going to like fold it up and get a box. All right, so what are we going to do? The total thing here is 18. It's all about drawing the right picture. If you can draw the right picture, you can definitely do this. We're going to make cuts of some size. We don't really know what size, so let's call the cuts X. X and X. And then everything will be X's. I'm not going to label everything. But, well, actually, I will label this because what's happening, right? So we start with 18, and then we cut X and X out of it. So then this little dimension here is 18 minus 2 X's. But then because this is X, we're also going to end up with this thing being 18 minus 2 X's. So the overall volume that we get, right? So on our figure here, this will be 18 minus 2x. This will be 18 minus 2x. And then this will be the x that we cut out, right? And then fold, 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 4 folds. Then tape, I guess, 4 tapes probably. All right, so what do we know about x? All right, so since the side in total is 18, and we're cutting 2 x's out of it, the smallest x cut that we can make, I guess, would be 0, but you don't really get a box, and the volume would definitely be 0. But x is definitely between 0. And then what's the biggest cut you could make conceivably? I mean, it won't work. You won't get a box. But x could be 9. If we make x 9, we are just like going to get like 4 pieces of cardboard and not a box, but it's definitely an upper bound. And what I like about that is that maybe I could use candidates test on this because now I have a closed interval. The volume will be 0 when I use 0 or 9, but that's not really a problem. So let's write a volume formula. So our volume is going to be x, which is the height, times 18 minus 2x squared, which is the area of the base. So area of the base times the height. We get this. All right, what can we do to this to make our lives easier? Well, there's actually a couple things we can do. One is we can make the observation that like a minus b squared is the same as b minus a squared. Work that out. If you don't believe that, that's actually true. It's one of those little gift things in math where you're just like, what? But it's true, even though it like looks insane. So here we can change our volume to be x and 2x minus 18 squared. Then 2x minus 18, let's go over here. Keep doing these in like different colors. 2x minus 18 squared is the same as 2x minus 9 squared, which is 2 squared x minus 9 squared, and then 2 squared is 4. So I'm going to rewrite this. So I'm not taking a derivative yet. I'm doing like a lot of work to avoid this being terrible. Make it 4x and then x minus 9 squared. Okay. What am I going to use? I'm going to use the product rule, I think, and see how this goes. So v prime is going to be the first. Now I need the derivative of the second. So I need to find, let's go back to the side again. The derivative with respect to x of x minus 2 squared is the same as the derivative with respect to x of x squared minus 4x plus 4, which equals 2x minus 4, which is 2 times the quantity x minus 2, which is what you might have guessed if you tried incorrectly to just power rule this thing. But it's like more complicated. Also, I did the entirely wrong thing, so that's fun. It's actually 2x minus 9. What can we fix? Can we fix it? I think maybe. So this was 2x minus, oh, it's wrong, right? So we should use a different color. 2x minus 9. So it's minus 18x and then plus 81. So that'll be 2x minus, I did not erase enough here, minus 18, which is 2 the quantity x minus 9. Okay. So that'll give us times 2x minus 9 plus the second, which is x minus 9 squared, times derivative of the first, which is 4. Okay, so what can we do? We can factor out an x minus 9. Actually, we can factor out 4 times x minus 9. And then that'll leave us with, so there's an x and a 2. So 2x from the first part. And then the last part, there's just a plus x minus 9 left over. So this is 4 x minus 9, and then I get 3x minus 9. Okay, so I can take out 3 from that. I don't really need to, but I feel compelled. So 12 x minus 9 and x minus 3. This all feels wrong based on how I've done this problem in the past, but like, I don't know, who knows? You know what we should do? Let's use a calculator, just confirm or refute what we've got so far. So we found that, let's do a new problem, doc4, enter. We have our volume as a function of x, we think is x times the quantity 18 minus 2x, and then squared, derivative of the answer with respect, nope, that never works. Derivative of v of x with respect to x, 12 x minus 5. Got it, perfect. All right, I guess I just like, something about the way I decided to tackle this problem this year has given me a clearer path to the derivative. I think what I often do is I don't do all that prep work with the factoring and, you know, the little side things there. And it's unquestionably worse when I do that. All right, so this is our derivative. So if our derivative equals 0, then either x is 9 or x is 3. So if x is 9 or x is 3. All right, so we have 2 critical points and we have a closed interval. I think what I'm going to do is actually the candidates test, right? So I'm going to say, so here we go. We're on the write-up stage, sort of. So v of x is continuous. Therefore, absolute max, which is what we're looking for, is at an endpoint. Go, do it. Endpoint or a critical point. Okay, so we know the endpoints and we know the critical points. So let's make a table. So we have x, and then we have v of x. And we said 0 and 9, and we said those were like ridiculous, but whatever, those are the endpoints, right? Like the smallest cut you can make is to not make a cut. The biggest cut you can make is to make the cut 9, because anything bigger than 9 and suddenly your sides are like negative, and that doesn't really make any sense. So 0, 3, and 9, we're gonna check. So we already know, so our volume is, where's the easiest one to plug into? It's probably this one, right? So our volume at 0 is definitely 0. Our volume at 9 is also 0. And our volume at 3 is going to be 12 times 36. So 12, let me just write that down. 12 times 36. So 12 times 36 is 12 times 12 times 3. So 144 times 3, which is like something. 144 times 3. Is there an easier way to do that? Maybe. 36 is 4 times 9, 4 times 3. No, there's like not really. So what is this? 532, I think. 520 and then 12, 532. Either way, I mean, it's the biggest that we're going to get, right? So we have this. So let's say, therefore, the max volume is when x equals 3 and v of 3 is 532. And then is the question about the dimensions, probably? Find the dimensions. So the dimensions are 3 by, so what it's 18 minus 2x, 18 minus 2x. So 18 minus 6, 18 minus 3 by 12 by 12. 12 by 12. And that is it. I think, let's check on the calculator. Let's make sure, don't jump the gun, right? We're not necessarily done yet. So we have this. Okay, so let's replicate our thing that we did, right? So we did, we found the critical points, and then we did v of 0, v of 3, 432. What? Why is that? 3? Oh no, 300. Okay, I'm gonna take another crack at that. A 4, yeah, geez. All right, and then v of 9 is 0. Okay, so we did it. What if we also graph this? I'm gonna go back and change that. The incorrect. I'm not that great at arithmetic, it turns out. Nor do you like really need to be in life. Let's see. Menu, let's zoom out. Menu 4, 4. It's nice to finish on a mistake. You know, you don't want people thinking too highly of you. All right, menu 4, let's box. Let's go here. Could have done the window thing. Oh, geez. Let's do that. Menu 4, let's just do settings, right? We know that it's between like, so I'm gonna go like -4 and 13 as my x's, and then I'll go like -50 maybe, and then let's do v of 3, and we'll add 50 to it. There you go, that's like a pretty good graph. So this is the algebra 2 way of doing it, which, like, you know, we could have done, except that doesn't involve calculus and we wouldn't have justified anything. There we go, 3 is the correct dimension. The volume should be 432, so let me go back and fix that on the notes. And then we will be done with this. And then I don't know, I didn't like prepare a speech, you know, I was kind of like unprepared. Let's change this and this. I don't really know what I got wrong. 144 times, so it's 300 plus 120 plus 12, 432. So I didn't do it right. That's what I got wrong. 432 cubic somethings. Are we in inches? Let's do that. 432. While we're here, let's just make it right. You know, inches cubed. There we go. All right. So that's it. That's math analysis. Good job, everybody. I don't know. I mean, if you're in my class this year and you're gonna take Calc AB, there's a chance that we will see each other next year. Otherwise, I wish everyone the best, and thanks for playing along. And I will I guess I won't see you in the next video unless you decide to watch more of my videos. Otherwise, good job. This has been quite the odyssey. So I'll see you around. Take care.